Could you go over number 26?
Sure. All right, so I am going to take out that worksheet and we'll look at number 26. We are going to wrap up the 2 solving equation problems using nth roots from the section 6.1 notes. And then we'll look at 2 application problems, again, solving an equation, but in the application form using nth roots. And then there's a practice worksheet that you will have for homework, just going over section 6.1. Tomorrow and Friday, we'll cover section 6.2 for the group B that'll be in class with me. You'll get to be in school tomorrow and Friday. And then group A, of course, you'll be home. Just a little friendly reminder before I forget, please make sure you are still submitting your virtual attendance if you are not in school. So you still do need to continue to take attendance anytime you're not physically in the building. All right, so 26 from the worksheet. So yesterday we did some of the problems. I tried to do one problem from each group with the students that were in class, and then that was recorded on the video. And in number 26, we have 1 plus 6 root 11, and we are dividing that by 4 minus 2 root 2. And the directions actually say to divide, because technically we are dividing. But instead of dividing, truly dividing, it's more of a simplifying problem. We are not allowed to have radicals in the denominator. So we're going to try and get that out. Ava R., what do we multiply by to try and get the radical out of the denominator?
Do you have to multiply by the square root of 2?
So we do have to multiply by the square root of 2, but not just the square root of 2. And the reason it isn't just the square root of 2 is that there's more in the denominator besides the square root of 2. So if this said 6 divided by the square root of 2, then the only thing in the denominator that we need to get rid of is the square root of 2. But because there's a quantity, we have to multiply by the opposite quantity, and that's called the conjugate. So we're going to multiply by 4 plus 2 square root of 2. That way, then, when we multiply these together, we'll be able to get rid of all of our radicals. So 4 plus 2 square root of 2. So essentially, whatever's in the denominator, we need to multiply by the opposite of that binomial. So that middle sign needs to change. And again, that's called the conjugate. That's the fancy word for it. So there's a lot of foiling involved here, because we have to FOIL the numerator and we have to FOIL the denominator. Get a smaller pen here. There we go. So this gives us a 4 and then 2 root 2. Then we're going to multiply 6 root 11 times 4. So the outside numbers are 6 and 4, and that gives us 24. And then we have the square root of 11. So make sure if it's outside, you're multiplying them together. If it's underneath, you're multiplying them together. And then the last terms, we have 6 root 11 and 2 root 2. So 6 times 2 is 12. And then 11 times 2 is 22. So if it was under the radical, it got multiplied together. So then on the denominator, we're going to do exactly the same thing. We're going to multiply the denominator together as well. So giving us 16. And then 4 times 2 root 2. Positive 8 root 2. And then negative root 2 times 4 is negative 8 root 2. Again, just the numbers outside are being multiplied because the 4 doesn't have a radical. And then the last one, I have negative 2 root 2 times positive 2 root 2. So that's negative 4 and then root 4. So it's a pretty big expression. Valeria, what happens with some of the terms in the denominator?
The 8 roots of 2 will cancel and add to 0, and then the root of 4 will simplify to 2.
Yeah, so this back term here becomes
-8.
-8. So then our denominator would be what, Valerio?
8.
Yeah, so the denominator now is 8, and that's the goal. So when we are working with radicals, the goal is to get a whole number in the denominator. That's the only thing that's allowed to be there, just a whole number. So if we look at our numerator, we still have the 4, 2 root 2, 24 root 11, and 12 root 22. Yep. Valeria, what do you notice about all the terms in the numerator?
They're divisible by 2.
And the denominator is also divisible by 2. So because everything is divisible by 2 with fractions, whatever you do to one part, you have to do to every single part. So all of the coefficients in front, which my little guy here is big, everything is divisible by 2. The 8 is also divisible by 2. So what you do to one, you have to do to all. So I'm going to divide everything by 2. So this becomes a 2. This is just root 2. 12 root 11, and then 6 root 22. And now that's divided by 4. Notice that the numbers underneath the radical did not change because they're a different type of number. They're a radical value. And I can only combine a radical with a radical, but the coefficients in front can simplify. Are there questions on number 26? That is a good question to ask and look at, kind of review. All right, so as I said, we have a few problems that we're going to talk about with solving equations in the packet today, just to kind of cover how to solve equations using nth roots. I will look at this worksheet and give you feedback on it. So sometime today you'll have feedback on the worksheet. And please look at those comments so they kind of understand the mistakes that you're making, and come next Tuesday's quiz, hopefully you don't make those same mistakes. So we will pull out the review or the packet that we're working on, chapter 6. I know this was Monday, so it was 2 days ago, but we were talking about nth roots, and then we were talking about rational exponents, so exponents that are in the fraction form. We're really going to be working with rational exponents tomorrow, and all the properties of exponents are going to come back into play as well. So we were on C, and I believe the bell was ringing as we were kind of talking about C. So we're going to look at C and D, and this is at the bottom of page 14. So C was in this group where we were trying to solve equations isolating x. Well, x was grouped together in parentheses. So in order to isolate x, we have to get rid of that cube. Instead of multiplying the cube and expanding the problem, rarely do you want to expand a problem and make it larger. The goal is to always try and simplify a problem. So we don't want to try and expand a problem and make it bigger. We want to take it and try and simplify it down. So you can take the cube root, since it's cubed, of both sides, and then the cube root and the cube cancel. That's the whole goal, to do the opposite operations. And what you're left with is x plus 4. And then on the other side, we have the cube root of 12, because it's an equation. What you do to one side, we have to do to the other. So then to finish solving this equation, we would subtract the 4 to the other side. It's a positive cube root 12. So then I would have positive cube root 12. So again, we were trying to get the x by itself, but to get x by itself first, we have to get it out of the parentheses by getting rid of the quantity cubed. So if you look at the cube root of 12, before you move on to the next problem, Ella, can we simplify the cube root of 12? Meaning, is there a perfect cube that divides or breaks down 12?
I don't think so.
Yeah, because the only perfect cube, the smallest one, is 2 cubed, and that's 8. So I cannot break down the cube root of 12. So that means this is the final answer. And remember, I know it was a while, but if you think back to chapter 4, when we were solving for x squared, in chapter 4, we had a lot of problems that said like x equals 2 plus the square root of 3 when we were solving using square roots in chapter 4, or when we were solving using the quadratic formula in chapter 4. We had problems that had answers like this. So this is just an exact answer, not a decimal answer. And no, we won't be writing these as decimals. So unless it's like a word problem, we usually do not use decimal answers. We keep things exact. So let's look at letter D yet. We have the quantity x minus 3 to the 4th equals 21. Brooke, what do you think you would do to solve this problem? X minus 3 quantity to the 4th equals 21.
You would do the cube root of both sides.
So I think you're correct, but instead of the cube root, what's the power?
At the fourth root. not the cube.
The 4th root, yeah. So just check out that power. I know it's weird saying it because we're so used to just saying square root. So now we have the 4th root. By taking the 4th root, our powers cancel and the radical cancels. So that's what an nth root does. Whatever the power is, if we take the nth root of that, it's matching power, then they cancel out. And we are left with x minus 3 is the 4th root of 21. And then Brooke, to solve this, you would just
Add 3, and it'd be 3 plus or minus the fourth root of 21.
awesome job. And look what she remembered. She said plus or minus. Brooke, why did you say plus or minus?
Well, we did like, it was like when we would do the square root of like x squared or something. I don't know. We would just always write plus or minus. I don't know how to explain it.
We did write plus or minus because a square root is an even exponent and a 4th root is an even exponent. And whenever it's even, a positive and a positive make a positive number, but a negative and a negative also multiply to be a positive number. So anytime it's an even root, we need to remember that plus or minus. If we look next door to letter C, this was an odd root. And when it's odd, there isn't a plus or minus because 3 positives make a positive or 3 negatives remain negative. It doesn't have that extra pair. So it only is a plus or a minus, whatever that quantity happens to be, the value of the number underneath. Nice job, Brooke, remembering that plus or minus as well. So 4th root is even, therefore, anytime we're solving for an even power of x, it's a plus or minus. Any questions? All right, so we have 2 final word problems on the back page. One is dealing with the population of a species, and then the other one, it looks like a little bit of a geometry reminder, which we do try and throw in. I mean, you had geometry last year, so it makes sense that we should be able to spiral some geometry back into algebra too. So the population P of a certain animal species after T months can be modeled by the equation. So P is population equals C times 1.21 to the exponent of T over 3. It says where C is the initial population. Find the population after 19 months if the initial population was 75. So they give us the basic function. So this basic function here represents a certain animal species. If I were a statistician, I would be kind of monitoring a species, collecting data, taking some points and thinking about how much the population changes each month, and then taking those points and creating a function. So that's what a statistician, one of their jobs might be, just to kind of monitor a species and then see how that fits mathematically to an actual algebra equation. So they give us the function, but they also give us some information to use in the function. So think about how would you use the information? Faith, what information do they give us that we can try and apply to the original equation?
The initial population was 75
Yeah, so we can plug that in.
after 19 months.
Oh yeah, that's also after 19 months. So that's two things that we can plug in. So initial population is the C. So we're going to plug in a 75 there. And then 1.21. And then she said 19 months. And that's time. So 19, and then it's over 3. So this problem is just an evaluating problem. We don't even need to solve for a t because they give us a number for t. Essentially, we just need to get a value for p, which is the certain population of this species. So if you want to go to your calculator, so we're going to see if we can plug this into the calculator. If you plug it in exactly as you have it written, you shouldn't have to plug it in separate steps. So it was 75 and then parentheses 1.21, I think. And then we have that exponent. And that exponent was 19 thirds. So we have our exponent. Use the little caret button for the exponent. The caret button is above the division sign. And then we have 19 thirds. That should be as our exponent. So your calculator should be identical to the equation that you have written down. So 75 is the initial population, 1.21 was given, and then our exponent is 19 thirds. And then hit enter. So I have 250.82. So it says find the population after 19 months. So we could say about 251, whatever our species is. We know we can't really have 0.82 of an animal. So about 251. Did anybody not get that number in the calculator? Okay, so the final question on here is our geometry problem. The volume of a cone is given by V equals pi r squared h over 3. So maybe you remember this formula from last year, volume of a cone. If not, we give formulas to you. They're also in your book, in the cover of the book, all the geometry formulas as well. A little reminder, h is the height of the cone, r is the radius. Find the radius of the cone whose volume is 25 cubic inches and whose height is 6 inches. So Gabby Snyder, what can we plug into this volume formula?
We can plug in the volume,
So what number goes in for volume?
25.
Yeah, so volume is 25. So now it's equal to 25. What else can we plug in?
And the height is 6.
Excellent. So height is 6. So we have a pi in the problem. We're going to keep pi there. We don't know r, but she said height is 6. And then it's divided by 3. So I'm just going to kind of pull this together a little bit. You do not have to do this step. This is just me organizing it. I'm pulling the 6 in front because it's our actual integer. So I just pulled that in front. And then we have the pi and then r squared and divided by 3. You don't have to write that step, but it's just me trying to pull it together to look a little nicer. So what are we trying to solve for here? Jaden, what are we solving for in this equation?
The radius.
Yeah, the radius. What do you think you'd do first to try and solve for the radius, Jaden?
Would you try and you want to try and isolate it. So would you multiply everything by 3?
So yes, we could totally multiply everything by 3. But if you look on this side first, is there any way we can reduce anything on the right side? Just to try and skip some steps.
Yeah, you could do 6 pi divided by 3.
Yeah, so we could take that 6 and the 3, and we could definitely reduce those. So yes, we're trying to solve for r, but let's try and reduce first, just to make the numbers a little better for us. Jaden, what you said was not wrong. It would just, make values a little larger. And if we can have smaller numbers instead of larger numbers, we'll probably make less mistakes. So 6 divided by 3 is 2. You still have the pi, and then you have the r squared. So now, Jaden, what do you think we would want to do to try and get r squared by itself? So right here is r squared.
Would you divide 25 by 2 pi?
Yeah. So whatever is with r, we're going to divide by it. And we're going to divide by both of those numbers, 2 and pi, because we want both of them to cancel. So the 2's and the pi's need to cancel. And here's where we are going to end up getting a decimal. So if I take that 25 divided by 2 pi in the calculator, pi is above the little caret symbol. So you have to hit the second caret symbol. And then I have that as 3.9788, blah, 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 blah. So that would be the number that I have. So then the last thing, Jaden, to get r by itself would be to do what with it? It says r squared.
You want to take the square root of the decimal, you got 3.978.
Yeah, so back to the calculator. We are not going to round this number. I know I had it rounded when I wrote it down. I was just writing a couple numbers down. I want you to use the second answer function of your calculator. So we're taking the square root. So there's my square root. And then if you hit this second button and you hit the minus sign at the bottom, which is next to the enter, above it, it says ANS. It pulls in your entire previous answer so that you're not doing extra rounding. Every time you round, you're changing the value. Because you're rounding and not getting an exact number. The less you round, the more exact your answer is. So by using this second answer function, again, it's the minus sign, the negative sign next to the enter. You are then not rounding that value. So I have 1.99 as my value for the radius. So yes, I have a rounded number here, but I want you to use the entire value. Use that second answer function. Now, when we're dealing with formulas, we need to make sure that we're still labeling. Any type of word problem, we have to label our answer. So the information that was given to us, it says we have cubic inches and then the height is in inches. So that means our radius would be in inches as well. We don't have a plus or minus because I cannot have a negative radius. Distance is positive. A length of a radius here of a cone is also positive.
This Kane,
Yeah.
I did this on I did the division on a different calculator, and then when you said pull in the same answer, I went to my graphing calculator, and when I tried doing 25 divided by 2 pi, I got 39.26 random numbers.
So when you have 2 pi in the denominator, you might have to group it together in parentheses.
Okay.
So try and group the two together so the calculator knows that both of them are being multiplied together. That might be what it is.
That works.
Okay, good. So you might not have been the only one that had that problem. So if you look at my calculator screen, that I have up here, I have that 25 divided by and then 2 pi in parentheses. And that way the calculator knows that both the 2 and the pi are in the denominator. So it's a quantity together. Otherwise, the calculator is just kind of reading from left to right, and it's taking 25 divided by 2 and then multiplying all of that by pi. So the calculator isn't as smart as you think it is sometimes. You got to make sure you're entering it in correctly. Awesome question, Brooke. All right, are there any other questions? So we're going to travel over to Google Classroom then. And the worksheet is posted for you. It posted a little bit ago. So I'm going to pull up the worksheet just so that you can see what it looks like. And then I do want to show you the calculator, just using a couple of questions with the calculator. And I apologize. This is the copy I have. It's a little crooked. So the first 6 problems are just rewriting it from the expression as an exponent or taking the exponent and writing it as a radical. And then 7 through 15 say evaluate without a calculator. You need to have work for those problems. So I should see the steps that you're using to find those values without a calculator. The next group are the problems that I'd like to show you how to use, just as a reminder to use this in your calculator. So number 16 says the cube root of 23 and then to the 5th power. So I'm going to change this into a rational exponent. So this is really 23, and then the exponent is going to be 5/3. So we cannot do this without a calculator because 23 is not a perfect cube, and multiplying it by 5 is not going to make it any better. So we're going to go to the calculator, and then we have 23. Use the little caret button and then just that 5/3. But make sure that exponent is entirely in the exponent location, that 5/3. Depending on your calculator, you may have to use parentheses for that as well. So 23 and then the little caret button 5/3. But again, you might have to place that in parentheses depending on the version of your calculator. So 186.01. Now it's just plugging into your calculator. Questions on that? All right, so I'm going to leave you with the remainder of class to kind of get a head start on this. So that's 16 to 22, you're just plugging them in, 24, you're plugging them into the calculator, just kind of getting used to using exponents in the calculator so we can kind of expand on that over the next couple of days. Does anybody have questions? If you do have questions, feel free to remain on Zoom. Otherwise, have a fantastic day. I'll see Group B in class tomorrow.
Have a good day.
Thanks, you too.
Thank you. Have a great day.
You as well.